Hi, Year 11. We're going to look at Year 11 Advanced reflection of functions. This is my second attempt at making the video after there was a software glitch in the first one. Okay, we've got to describe the following graphs with dashed lines of the reflections in the x and y axes. So let's have a look at the blue graph there. And we're going to compare the red graph with the dashed lines, to the blue graph. Now, hopefully you can see that the red graph is a reflection of the blue graph in which axis? The y-axis. Okay, you can see that this point here is reflected over here at this point. This point here is reflected over here at this point. You can see that the mirror points are actually the same distance from the y-axis as the original point. Second point up here, this point here is the same distance from the y-axis as the reflection point. Okay, so let's just draw a few pictures here, a few little dots. So this point here is reflected in the y-axis over here. Okay, and this point here is reflected in the y-axis over here. You can see they're the same distance, 2 units from the y-axis here and 2 units from the y-axis here. Here, this is 1 unit, and this point here is 1 unit as well. Coming up here, this point here is reflected in the y-axis over here. So you can see here 1, 2, 3 units from the y-axis and 1, 2, 3 units from the y-axis here. The other thing to note is the mirror point is the distance between the mirror point and the original point is the perpendicular distance. Okay, so if I draw a line from the mirror point, it should be a straight line, of course. Straight line, there we go. It's a 90-degree distance with the mirror. Okay, so the mirror point is the same distance from the y-axis as the original point. So that distance there equals that distance there, and so on. Okay, so let's complete our little sentence down here. Y equals 2 to the minus x is the reflection of y equals 2 to the x in the y-axis. Okay, now the other thing to remember is that we're talking about other functions as well. What if I said the original function is y equals f of x? That means the reflected function is f of minus x. So I could say that y equals f of minus x is the reflection of y equals f of x in the y-axis. Okay, let's move on. What about this one here? We can see here I've got a blue line and then I've got a red line which has got dashes for the line. How can I describe the red line as a reflection of the blue line? Well, hopefully you can see that the x-axis here is the mirror line. Okay, so if I look at this point here, the mirror point is the same distance from the x-axis. If I look at this point here, the mirror point is the same distance from the x-axis. Okay, if I look at this point here, the mirror point here is the same distance from the x-axis. Okay, so again, the distance we're talking about between those is the perpendicular distance. Okay, that's at 90 degrees. Oops, it's meant to be a straight line, of course. Okay, that's meant to be 90 degrees there. Okay, now remember the distance from the mirror line is the same. So that point on the blue line is the same distance as this point from the mirror line. So each mirror point is the same distance from the x-axis as the original point is. All right, so let's have a look. What can we write down? Y equals minus 2x plus 1, which is the red line, is the reflection of y equals 2x plus 1 in the x-axis. Okay, now just like before, we can say the original function is some function f of x, and the reflected function in this case will be y equals minus f of x. So I could say that y equals minus f of x is the reflection of y equals f of x in the x-axis. So that's what we'll write down here. So you've got y equals minus f of x. It's just y equals f of x reflected in the x-axis. And y equals f of minus x is just y equals f of x reflected in the y-axis. Okay, so that's our conclusion. Let's now look at sketching. So we're going to sketch the function y equals minus f of x on the number plane below. Now, if you go back up to the top here, y equals minus f of x is a reflection in the x-axis. So this time our mirror line is the x-axis. So let's just get a straight line there, just as a reminder. So that pink line is going to be our mirror line. Okay. Now, let's have a look at reflecting. So first of all, let's look at the x-intercepts, or any intercepts for that matter. Let's look at reflecting the intercepts. So now this point here and this point, all the x-intercepts are on the mirror line, so they actually won't move. They'll stay where they are. Now, what about the turning point? So I've got a turning point here. That's going to be reflected up here. So that'll be like a little local maximum then. And this point here, which is about 2 and a bit units above the x-axis, that'll be same x value. That'll be 2 and a bit units, maybe down here. So that'll be a local minimum. Yep. We could choose a few others. So let's take, for example, this point here. That's 2 and a bit. So I'm going to come down 2 and a bit. There's another point. Now what about this point here? That's 2 units. So I'm going to count 2 units up, and that maybe is about there. So we're now ready to sketch. So maybe starting from here. And then coming down. There's my turning point. And through my intercept, another turning point down there, through my other intercept, and then down here, just missed. Okay. All right. So there's my point there. Okay, so the points that you want to reflect are the intercepts. You also want to reflect any turning points as well. And also you can just pick some other random points to help you. Okay, so start with the intercepts and turning points and then do other points. Okay. All right, next. Don't forget to put the arrows. Okay. So that orange function is the reflection of the black function in the x-axis. Okay. Now, what about this one? Sketch the function y equals f of minus x. Well, this will be reflected in the y-axis. So let's just get a straight line. There we go. And that orange line there, that's going to be the mirror line. So let's look at the intercepts again. Okay, so for the intercepts, again, we're going to start with, say, the x-intercept here. Now, if I reflect this in the x-axis, that is going to be 1 unit from the x-axis. And what about this one over here, which is the -4? If I reflect that in the y-axis, that's going to be over here, 4 units. And what about the origin? Reflect that, that'll be just staying at the origin. Okay, let's do some of the key points. So what about the turning points? So this turning point here, that's going to be just about there, and it's still going to be a local minimum. This turning point here will be 2 and a bit units to the right of the y-axis, 2 and a bit units, so maybe about here. Same height as before. There we go. And let's pick some other points. So maybe this point here, that's going to be 2 and a bit units to the right, so maybe around about there, roughly. And some other points. What else? Okay, how about if we grab one of these points here? Down here, I've got 4 and a bit units. It'll be down here somewhere. I'm just doing my other points now. And what about, yeah, I think that'll do. That'll do. We could choose a point here. That'll be 1.5 units, maybe around about there. And all right, so we're ready to sketch. I think that's enough points. You don't need too many. So we're going to start from here, coming down through the intercept, turning point there, coming up, turning point there, then down. Okay, something like that. It'll do. Didn't go through that one. All right, so that's close enough. So that's a reflection in the y-axis. Okay. Now, last question. What happens if we've got 2 minuses, a minus here and a minus there? That means we've got a double reflection. So, again, we'll start off with the intercepts. So, we have... Well, let's start off with the easy one. If I reflect the origin in the x and y-axis, that stays where it is. If I reflect the 1 in the y-axis and in the x-axis, that will stay there. If I reflect the -4 in the y-axis and in the x-axis, that will stay there in that position. Now the turning points though, if I reflect this turning point across and then up again to reflect on both axes, so that's like a little local max. This turning point here, if I reflect it in the y-axis, that'll be 2 and a bit, and then 2 and a bit down here, so that'll be a local minimum. What else? What if I had a point over here? Okay, so I reflect that by about 1.5 units across, and then 1 unit down, so it'll be about there. So we're kind of in a position almost to sketch it. What about we choose another point? So I reflect, I want to get another point over here. I think that's enough. Yep. So just sketching through there, turning point, coming down here, another turning point, and then turning point here, and all done. That's it.